Hey guys, I'm doing one of day 29, which is on double integrals in polar form. Specifically, we're going to find the area and volume in with equations, set them in polar form, and find the area and volume of them. So this will be of like dr d theta kind of thing with double integrals. So our first question, we're given a horizontal line y equal root 2, which is going to be like a straight line across, like parallel to the x-axis, and the circle x squared plus y squared equal to 4, so the radius is equal to 4. So I have a representation right here where I label the points, but before we get to that, we're going to do the representation up here. So it's just a circle with a line horizontal to the x-axis right here, and it's equal to root 2. So the first thing we're going to do is we're going to solve this because it's in the form of x squared plus y squared equal to r squared, and we want to know what r squared is, the r value, well, r. So if we take our x squared plus y squared, root both sides, we're going to get x squared plus y squared equal to root 4, which is 2. And now we take our y value, y is equal to root 2. If we convert that into polar coordinates, then to convert to polar coordinates, it's just r cos or r sine theta for the y, and x is equal to r is equal to x cos theta. So we just divided sine theta by both sides. That's why we have the r equal to root 2 over sine theta. And then we're going to go to our representation. So I drew a graph here, and we're just going to label it. So we know on the points that we're trying to find, so this is the circle, and we want to find this region here to this region because that's what the instruction had. And we know that the radius, so the r value, because we're in polar coordinates, it's r and theta. So instead of x and y, it's r and theta. So our r anywhere along this circle will always be 2, because that would be the radius of the circle. And then our theta is what's changing. So our theta right here is pi over 4. And then our theta right here is pi over 2. It's easy to see the theta being pi over 2 right here because it's like 90 degrees. And over here it's pi over 4 because of what we have here when we worked it out. So if we do sine inverse to find the theta, using 2 is equal to root 2 over sine theta, because we got 2 r being equaling 2 from here. We set these two equations to equal to each other, so these two that we got earlier, we get theta over 4 is equal, pi over 4 is equal to theta. So we know that that's right here. So we have our two most important coordinates right here and right here. And now we know our bounds of integration. So we set up our bounds of integration with which for area it's going to be 1 for the f of x y. I don't have the f of x y here, but it's equal to 1, so I didn't show it. And then it's just r, dr d theta. And our bounds is theta outside, r inside. So it goes from pi over 4, so it goes from here all the way up to pi over 2. And then it goes from over here, which is, it goes from here, which is root 2 sine theta, that's where this line is right at, to all the way up to 2. So I didn't show it right here in my coordinates, but it is root 2 over sine theta. And we're going to go ahead and integrate that. I use a calculator to make it easier. And when r evaluated at 2 and root 2 over sine theta is going to give 2 minus cosec squared theta. And then we're going to go ahead and integrate that again for theta over 2 and pi over 2 and pi over 4. Again, I used a calculator, and I ended up with this as my final answer, pi over 2 minus 1. Because pi minus pi over 2 is the same as pi over 2, because it's like a half of it, so you subtract a half, you're going to leave a half left, minus 1. And then the other question wanted us to find the volume. So The other question wanted us to find the volume, use double integrants to find the volume with a sphere of radius a. So we only really need to know the radius, because if you know like the general formula for a sphere, like the volume for a sphere, the only thing that's not constant in that is the r. So we're gonna set, and then this is the general formula for a sphere. It's just like a circle, but there's one more plane, so that's why we have the z squared, and we know that's equal to a squared, which is the radius. So x squared plus y squared for a circle is equal to r squared, but for a sphere it's x squared, y squared plus z squared, another plane since it's three-dimensional, equal to a squared. Let's make z the subject and put x squared plus y squared. We know that's equal to r, and that's what we're trying to find to put back into the equation. So we have z is equal to plus or minus a squared minus r squared, and that's the function we're going to put in the equation. Our bounds of integration, we know for a circle we're going from 0 to, for a sphere, sorry, our theta value will go from 0 to 2 pi. We're going from the lowest, like the least max, to cover the most ground of the sphere, because we're covering all of the sphere. And we're going from the radius being 0, which is at the origin, to the radius going all the way up to a. That's the radius we're given. The 2 is here because that would give me the volume of a hemisphere, and 2 hemispheres will make a full sphere. So that's why the 2 is right here. There are other ways to do it, but this is just simpler in this scenario. And I'm going to go ahead and integrate that. So we have 2 times 0 to 2 pi. So did some math here. It's like some chain rule stuff. Again, I used a calculator to make it more precise, but we'll have a 1, negative 1/3, 1 over 2, negative half multiplied by 2/3 coming from the r that was right here, getting integrated, and we're going to end up with 2 to 0 to the 2 pi minus 1/3. If we put in a for r squared, it's going to cancel 0, and if you put in 0 for r squared, we're going to get a squared. So that's where this a squared minus 3 over 2, and this negative will cancel, times it by 2, we're going to get 2/3, so I just bring that out. Again, we'll evaluate from 0 to 2 pi, a to the a cubed, cause 2 times 3 is 6 divided by 2, give us back 3. That's why we have a to a cubed. And then d theta, and then this is equal to 2 over 3 a cubed 0 to 2 pi, and then just simplifying this until we get 4 over 3 pi a squared, which is similar to the formula we know for a sphere, which is 4 over 3 pi r squared. It's just that, again, they told us r was a, and this is basically like a proof for that volume formula that we have for a sphere.